Greetings, YouTube, for this early morning April Fool's Day stream. So I'm going to go ahead and stream the lecture for now. Again, my intent is to be available during class time. A few notes for my students as you all watch this presentation. So this is we're approaching the end of week 3. We're approaching the end of week 3. So what that means is next week we're actually on spring break. So I want you to do your best, the best you can this week. You want to get your assignments in on time. And I'll go ahead and post. I think we need to do a quiz this week. So we'll have quiz number 2 for week 3. You'll see that on Pearson. A few notes. Let me see. The first thing is make sure that your GMC email is being forwarded to an email that you check on a regular. The main way that I communicate with you all is via your GMC email. Okay, so you want that to be forwarded to an email that you check on a regular. So that way, as I make announcements, you can be up to date, and there's no issue there. Second thing is everyone should have full access to Pearson. I see I'm going to have to make a few phone calls because I see that I have at least 2 students that still have temporary access. I think that's correct. So, just kind of, we'll be anticipating that kind of communication. But because of the climate and everything that's going on, we're able to get full access to Pearson. So, we're approaching the end of week 3. We've already had exam 1 due. We've had quiz 1. We're going to be moving into quiz 2 this week, okay? All on a weekly basis. Assignments are due weekly on Saturdays at 11:59 p.m. Let's see. So we're forwarding our GMC email, so we're staying on top of our communication. The second thing is that we are getting our assignments submitted as promptly as possible on Pearson. Keep in mind that you can actually work on all assignments past the due dates, but it'll come at a penalty. What I mean by that is on any given assignment, the highest that you can make is a low B at an 80%. And you can actually submit your exams past the due date and up until a final date, because there is a date where I have to go ahead and push grades, right? And exams, you can actually, the highest you can earn on an exam that's late is a 79, which is a high C, similar to the drink. That's probably a really bad dated joke, I realize, but I don't care. Let's see if there's anything else. I'm not going to worry about that right now. Let's do like this. Presenter view. I guess, let me see if I do like this, see if it works. Presentation. I'm gonna try this. I'm gonna see if this works a little bit better. I'm gonna give this a go. Yeah, so like, anyway, that's none of your concern. Okay, so let me see again, the checklist. So 1, we're having our GMC emails. We're having our GMC emails forwarded to an email that we check on a regular. 2, we're getting our assignments. We all have full access to Pearson, and we're getting our assignments submitted promptly on Pearson. And then 3, we have full lectures on YouTube. So obviously, if you're watching this channel, this video, then you're at least aware of our full lectures on YouTube. But the third checkpoint is that make sure that, I do my best to have the videos pre-recorded and loaded for each class before class. And so my intent is to be available during class time just for questions, right? Kind of just organization, updating my grade book, making phone calls, checking on students. Like if I see that grades are low or assignments are missing, I'm going to come looking for you. That's all that I can think of. So on that note, we shall overcome. Okay. So let me see. Can I do this? Awesome. I'm liking this. So yeah, so I'm kind of geeking because not Pearson, Notability, this note-taking software that I'm using, they've done updates. So this is actually a new feature called Presenter View. I noticed it before, but I hadn't like investigated to see how it worked or what it was about. But this is a Presenter View. None of your concern. You don't really have to worry about that. So we're gonna move into today's lecture. Let's see. Can I scroll? I can scroll, but I'm gonna do this. Can I change that? the dimensions. That would be nice if I could change the dimensions, because I don't really like the way that looks. I'm just trying to make a decision on what view I want to use. I think I'm gonna switch it back to the screen for now. I might flip between the two, but anyway, okay. So today, with today's lecture, I just want to go through two sections. It should actually be a fairly light section. We're actually on schedule. I've been kind of I'm doing my best to follow Moodle. Okay. So on any given week, you can check Moodle to see what to anticipate. I think this week we kind of went back and made sure to go through chapter 10. So we did chapter 10 on Monday. So today we're going to do 7.1 and 7.2. We do have an extra section in there. Really, what's recommended is just do the assignments that are on Pearson. So I may or may not post homework for 7.1 because we really don't need to go through it. But I just wanted to talk about it. If you want to skip fast forward in this presentation to section 7.2, that's totally fine. I still hadn't decided if I'm gonna do homework on 7.1 or not, but I did want to take some time to kind of go through this section. And then, but the official lecture really starts on 7.2, but I still want to go through 7.1. So we're going to go ahead and go through 7.1, the Cartesian coordinate system and linear equations in two variables. So some objectives here. We want to plot points on the Cartesian coordinate system and determine whether an ordered pair is a solution of a linear equation. So some definitions. We have a graph as a picture that shows the relationship between two or more variables in an equation. The Cartesian or rectangular coordinate system, named after the French mathematician and philosopher René Descartes, 1596 to 1650, consists of two axes or numbered lines in a plane drawn perpendicular to each other. Okay, we'll see this in a moment. So it looks like this. This is the Cartesian coordinate system. The two perpendicular axes form four quadrants, numbered 1, 2, 3, and 4. So this axis is our x-axis here. It's a horizontal. Horizontal means side to side. Our positive x is here. That's why we have an arrow on this side, and you see the x here. So this means that this is our x-axis, and the positive x goes in this direction to the right. And then perpendicular means that it crosses at a 90-degree angle, right? 90-degree angle is like the corner of a book. So then on the vertical axis is our y-axis. The positive y goes off in this direction. You see the y here, okay? So then doing these two axes, making this at a 90-degree angle, crossing them at a 90-degree angle makes this image. And so what it does is it breaks a flat surface up into four sections. We have this upper right, which we call quadrant 1, upper left, which is quadrant 2, bottom left, which is quadrant 3, and bottom right, which is quadrant 4, right? So the two perpendicular axes break the flat surface up into four quadrants. The horizontal axis is the x-axis, and the vertical axis is the y-axis. So the point of intersection of the two axes is called the origin. So you see it here in the center. The coordinates, or the values of the x and y, determines the point. This is also called the ordered pair, written as x, comma, y. So we'll have these ordered pairs is basically telling us how to get to these points, right? So the first coordinate is always our x, or our independent variable, and the second coordinate is our y, which is our dependent variable. Okay, and these tell us basically if we start at the origin, x tells us whether we go left or right, and y tells us whether we go up or down. Okay. So plotting a point, we're asked to plot the point 4, 3. So if we're going to plot the point 4, 3, what we want to do, we're going to start at the origin. Since x is positive, we go in the positive x direction for 4 steps. So we're going to go 1, 2, 3, 4. And then since y is 3, positive 3, we're going to take 3 steps in the positive y direction, which is up. So we're going to go 1, 2, 3, and then we put a point, right? So this will become second nature if it's not already second nature. So that's how we plot points in the Cartesian plane, okay? Unfortunately, this one is already done for us. I mean, we could do it, but for the sake of time, I'm not, and I think it's okay, right? So for instance, if we're looking at this first one, we have the ordered pair 4, 3. So what it's saying is if we start at the origin, x is positive, so we go 1, 2, 3, 4. And then y is positive 3, 1, 2, 3, and here's that point right here. The next one is 3, comma 4. So x is 3, y is 4. So if we go right 3 and up 4, 1, 2, 3, 4, you see that point right here. I'll do E just to be a little different. So for instance, if we wanted to plot E, this is saying x is negative 2 and y is negative 3. So if we start at the origin, x is negative 2, so we go left 2, and then y is negative 3, so we go down 1, 2, 3, and you see that point right here, all right? So that's a little demo on plotting points in the Cartesian plane. Let's see what we have next. Okay. So linear equations in two variables. A linear equation in two variables is an equation that can be put in this form: ax plus by equal to c, where a, b, and c are real numbers. And these are some examples of some linear equations, right? All of these, okay? So the solution to an equation is the ordered pair that can be substituted in an equation without changing the validity of the equation. So for instance, this first question says, is the ordered pair 3 comma 0 a solution of this equation? So again, if it's a solution, what that means is if we plug this point into this equation, so our x is 3 and our y is 0, if we plug that in, does it make it true or does it make it false? If it's a solution, it should make it true. If it's not a solution, it's going to be false, right? So we're going to replace the x with the 3 and the y with the 0. So here's a copy of our original. X replaced with 3, y replaced with 0. Notice that 3 times 0 is 0. So 3 times 0 is 0. 4 times 3 is 12. 12 is indeed equal to 12. That's true, right? So then we could say yes, 3 comma 0 is a solution of this system or this equation. So a graph of an equation in two variables is an illustration of the set of points whose coordinates satisfy the equation. A set of points that are on a straight line are said to be collinear. The prefix co meaning together or with, and linear meaning line. So then you have collinear means on the same line, basically. Let's see, do we have an example? Yeah. Determine whether the ordered pairs, okay, well, I know we have the solution here. Determine whether the 3 points appear to be collinear. All right. So are they on the same line? So what we could do, plot the first 2 points. All right. So 2, 7 over 2 and up 7. You see that point here, and then 0, 3. So we don't go side to side, and we just go up 3. We can connect those with a straight line. We'll get something like this. Then we plot the third point, -2, which is here, and down 1 is here. And notice that does fall on the line. So we plot the points, and they do appear to be, they do appear to be on the same line. Let me see if I can get some better examples. Okay, let's try this one without seeing the answer. I don't want to see the answer, all right? Well, I mean, I feel like it's not that difficult to plot. So I'm just going to kind of breeze through this one a little bit. So if we have the point 0, 5, we're not going to go side to side. We're only going to go up 5 and plot a point. The next one is 5 halves. So what that is saying, that's x is like 2.5. So we'll go right 2.5, then we don't go up and down, we plot a point. And then we see if over 5 and down 5 is also on that. And I think if we look at it, it looks like these are collinear. Okay, that's fine. Do you have another example? Okay. So with this one, now notice, if we plot -2, -5, we go left 2, down 5, we get a point here. If we plot the point 0, 1, we don't go side to side, and we just go up to 1, and we're here. We connect those with a straight edge. Then we plot the point 6, 8. So if we go over to 6 and up to 8, notice that is not on the line. So these are not collinear. Okay. Determine which of the following ordered pairs satisfy the equation. Okay. So basically, all they're asking us to do is plug each of these in, right? When x is 2 and y is 0. 2 times 2 is 4 plus 0 is 4, so I would say yes to this one. You see it here. If x is 0 and y is 4, so we get 0 plus 4, that indeed equals 4. And we should be writing this out. I know I'm not, just for the sake of time, but as you kind of work through these, you definitely want to like write this down. So in instance, since we don't have the solution already shown for this one, we're going to go ahead and try 3, 1, right? So when x is 3 and y is 1. So here's a copy of the original 2x plus y equal to 4. Then we're going to say 2 times 3 plus 1. The question is, does that equal 4? 2 times 3 is what? 5. I'm sorry, I did 2 plus 3. 2 times 3 is 6 plus 1. The question is, does that equal 4? 7 does not equal 4. So then we would say no to this guy. And let's go ahead and do when x is negative 1 and y is 6. So if we have 2 times negative 1 plus 6, the question is, does that equal 4? That's going to be a negative 2 plus 6. Again, does that equal 4? 6 minus 2 is indeed 4 equals 4. That's true. All right. So it looks like the only one that's not a solution should be, is that 3, 1? Or is that 3? Sorry. It looks like it's the 3, 1. Let me clear all this out. So it looks like we only had one that was not a solution. Right? The order of pair 3, 1 does not satisfy the equation. Okay. Plot all points that satisfy the equation on the same axis and draw part B and draw a straight line through them. Okay, so they did it for us. If we plot those points and draw a straight line through them, we get this. What does this line represent? The line represents all the solutions 2x plus y equal to 4. The coordinates of every point on the line satisfy this equation. All right, so if we find any ordered pair on this line, they're going, when we plug them into the equation, they're going to make them true. Oh, my sleep is catching up to me now. Okay, but let's press on. Let's see what's next. So I think that might, yeah, that actually closed out 7.1, and now let's take some time to go ahead and move into section 7.2. Also, so keep in mind, I do plan on being available during class time for questions. I'm probably just kind of keep working on updating my grade book. The grades for week 2 are processed. I'm just going to update our Moodle grades. Another thing, so for this course, we do have to have mandatory tutoring hours. Let's go ahead and commit to 2 hours at least a week of linking up with a tutor. This is going to be for a grade. So I will probably start logging those grades this week. And so I know we're going to get a report, like they're going to send me a report of who has and has not been attending tutoring. So again, for this course, we have required tutoring. Let's go ahead and commit to at least 2 hours every week with a tutor. I think I did send an announcement on how to link up with the tutor. I think he tutors Tuesdays, Wednesdays, and Fridays. Okay, from like, I forget the hours. Don't give me the line, but it's in the announcement section on Moodle. So this is why, again, you know, the whole thing. So yeah, we have required. We do have mandatory tutoring for this course. Okay, so be sure that we're logging at least 2 hours with a tutor every week. I'm available. Okay, and I usually try to reach out when I notice that somebody is not doing what they should be doing, and I just, you know. But be sure to get those 2 hours a week with a tutor, okay? And he basically hosts a live a Zoom session. He's just there, and you know, you log in and you can ask him questions. You can also just log in and ask me questions as well, but you know, I totally get it. Okay, so the tutor is just kind of sitting there waiting for you. All right. So moving into section 7.2, graphing linear equations. Okay, let me see. Oof. So some objectives here are to graph linear equations by plotting points, graph linear equations of the form ax plus by equal to 0, graph linear equations using the x and y intercepts, graph horizontal and vertical lines, and study applications of graphs. Okay. So in order to graph a linear equation by plotting points, solve for y. So we want to get the equation with the y variable by itself, okay, on the left side of the equation. Substitute a number in for x. Select a number. So choose an x, and then you find the corresponding y, and then repeat this step. So select multiple values of x. This will give multiple values of y and multiple ordered pairs. Plot the points, and then that'll give you a sense of the graph. The more points that we plot, the better sense the better sense of the graph we'll get. All right. Plot the points and then draw the line with a straight edge. Okay. Let's see. Graph. Didn't really want to see all of this. Okay, let's do this one from scratch. We're asked to graph this one, so we're going to graph this one by plotting points. Let's see. So let me do the following. Let me switch this to this. Let me get a copy. I think I'm going to trash that one. And then this one, I just want this. Cool. I'm glad that you can't see all this. Right here. Okay. Then we want to take that and drop it right here. And we want to add a page. Boom. This is exactly what I want. Okay. Yeah, I like this update. So now I can like open up all these things on the side, and I could have kind of like done some things so that you couldn't see all those edits that I was doing before, but anyway, I like this update. I like how everything updates, and they're always improving all these different apps and things that we use. Let's go paper. We're gonna introduce some graph paper. Okay. So now we're asked to graph this. We have y equals 2x plus 4. Let's see. First, I'm going to start by making a table. What color am I filling? Let's just do black for right now. So I'm going to do my table side to side. I'm going to say, so say we have an x and we have a y. Okay. I'm going to let x be, let's go -4, -3, -2, -1, 0, 1, 2, 3, and 4. I just chose some values of x. Now let's find the corresponding values of y. -4 times 2 is -8. -8 plus 4 is -4, right? -6 plus 4 is -2. So the next one should be what, 0? Yeah, 0, and then what? Basically just keep adding 2 for these, right? 2, 2, 2, 4, 6, 8, 10, and it should be 12. Let's check the 3, right? 3 times 2 is 6, plus 4 is 10. So we have this table. I just did mine side to side for economy of space, right? So then to graph this by plotting points, we're just going to plot points. I'm going to, I guess x's go from basically -5 to 5. Y goes from -5 to like 15. So let's see. I'm going to go, let's put our origin like about here. Let's see. So we need to go 1, 2, 3, 4, 5, and then we need to go up to like 15. Let me see if I have enough space. 1, 2, 3, 4, 5, 6, 7, 8. So I think I might go by 2s, so that way that we can reach where we need to go. And then x's, we can definitely go by 1s. 1, 2, 3, 4, 5 is more than enough. 1, 2, 3, 4, 5. So then our positive x goes off in this direction, like this. This is our positive x. Our positive y goes in this direction. This is our positive y. Okay. Let's see. X's, we can say, so the origin is here. We're going to say 1, 2, 3, 4, 5. We have -1, -2, -3, -4, -5. But I wanted my y's to go by 1, but I didn't have enough space, so I'm going to go by 2. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. And then -2, -4, -6, -8, -10, right? Okay, so now let's plot these points. So we have the point -4, -4. So we go left 4 and down 4, and we put a point here. Just gonna copy that. Copy. Let's see, let's paste. So now for the next ordered pair is -3, -2. This says go left 3 and down 2. We put a point there. Okay, the next point is -2, 0. So we go left 2 and we don't go up or down, so we put a point. The next one is -1, 2. So we go left 1 and up 2, and we have that point. Then we have the point 0, 4, so we don't go left to right, and then we just go up to 4 and we put a point. Then we have 1, 6, so over 1 and up to 6, and we put a point. And then we go 2, 8, so over 2 and up to 8. And then 3, 10 is here. And then 4, 12 is here. And then we just want to connect those with a straight edge. So let me see. And we want to extend this graph. I'm just going to go ahead and plot, like, I know if it's 4, 12, it would be 5, 14. I'm going to just go ahead and continue the pattern to fill the graph. We want to fill the whole Cartesian plane. Okay? And if I did -5, that should be -5, -6. All right, here, right? So we're going to draw a straight edge through all of those. So then, like this. And that's going to be the graph, all right? Okay, that was fun. All right. So let's see, how do we do? And I'm going to actually switch it back to this view. So we plotted several points. Now, they just said I plot the 3 ordered pairs. Notice that the points are collinear, right? They just did 3, which is fine for this context. I just did a few extra just because. But you see how, like, the more points we have, the easier it is to get a sense of how the graph is behaving. So let's, okay, let me see. They're still making a table. They're still making a table. I mean, let's do another one. Let's do one more, just for good measure. So I'm actually going to switch this back. I would like a copy of that. I'm going to delete that one. This one, I just want this to there. I can get rid of this and that. Let me see. Okay. So then let's put you here. And let's go like this. There it is. Okay, we want to add a page right there. Awesome. And this. Okay, so let's give this one a go. That's so interesting. I'm really liking this. I'm geeking. Okay, so something similar. Let's just make our table again. I guess we don't need so many points. Let's go. Ooh, let's see. We're gonna have some fractions with this one. Okay, for the sake of simplicity, because it's a straight line, we really only need 2 points, right? We know it's a straight line because the highest exponent is a 1, right? So we only really need 2 points. So the main 2 points, let's go ahead and find the x and y intercept. So let's see, if say we wanted to find the y-intercept, we're going to set x to 0. So when x, let me do this like this. So when x is 0, then we'll have the following thing happen. If we set x to 0, we're going to have what? 2 times 0 plus 5 times y equals 0. Notice that this goes to 0. Okay. So then we get this. We get y equals 0 divided by 5, right? If we get this, what does this equal? Does this equal 0 or is this undefined? Okay. So let's do this. 0 over some number, this is okay. So this is going to be equal to 0 versus some number divided by 0, that's a KO. You want to knock that out. So this does not exist, all right? We cannot divide by 0. So 0 divided by some number, that's okay. But some number divided by 0, that's a KO. You want to knock that out. So that does not exist. So in this case, this is actually going to be equal to 0, right? So then as far as the intercepts, we get the origin. So then we do need to find at least one other point. So we're going to say, okay, let x be, let's do a couple more. Let's do when x is 3. Let me see if it's 2 over 5. Subtract. Let's do when x is 5, and we'll also do when x is negative 5. Okay, we'll just do those. So when x is 5, we want to find the corresponding y. Let's see. So then we're going to say 2 times 5 plus 5 times y equals 0. If we solve for y, 5 times 2 is 10. So then we get 5y equals negative 10. Divide both sides by 5. Y equals negative 2. So that first ordered pair that we found was the origin, 0, 0. The next ordered pair that we just found was the ordered pair 5, negative 2. And then let's go ahead and see what happens when x is 5. Sorry, negative 5. So then we're going to have 2 times negative 5 plus 5 times y equals 0. That's going to be a negative 10, so that means that 5y is going to be equal to 10. Y is going to be equal to 2. So then with that one, we get the ordered pair negative 5, 2. All right, so let's plot these points. Okay. So x's and y's. So let's say the origin is about here. Let's go 1, 2, 3, 4, 5. And then essentially want the same thing on the other side. Right there. And then the y's, we only need to go up about 3. 1, 2, 3. That's more than enough. I'm just going to copy that and paste. Okay. So our positive x goes in this direction. Right here is a positive x. Our positive y goes in this direction. Here's a positive y. And let's plot these points. So the first point that we got was the origin. Let's see, is that other one still there? Nope. I can copy. Let's copy that. I don't know. I'm being a little bit OCD. Copy, undo. All right, we're gonna borrow that for right here. Paste. Cool. Okay. So the first order pair was the origin, so we have a point there. The second one that we found was what, 5 comma -2. So if we're going to plot 5, -2, 1, 2, 3, 4, 5, 1, 2 is there. Let me label my axes. So this is the origin. This was 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, 1, 2, 3, -1, -2, -3. Okay. And then the other one that we found was -5 comma 2. 1, 2, 3, 4, 5. 1, 2 is there. So then if we connect these with a straight edge, we'll get the following. So I'm going to go from here through here. And then what I want to do, yes, like that. Can I just extend it? So I want this line to extend. Let me do the following. Let's see, 1, 2, and then 5, right? So then 1, 1, 2, 1, 2, 3. I just want to extend this line, so I'm just going to kind of go like this and just eyeball it. That's fine. Okay. So then we get something like this. I just wanted the line to extend across the whole Cartesian plane. All right. So we graphed that one by plotting points. So let me see. So for the quiz for this week, more than likely it'll be over chapter 10 and chapter 7. I'll go ahead and try to get that created and get Pearson updated so you all can be working. It's, do the best you can with the work on Pearson. And over the spring break, it's a good idea to take a break. I mean, do your best to kind of get your assignment submitted, but take a break. Like, put this stuff down, try to play, I know we can't really go outside, or we're not really supposed to or whatever, but you want to still like jump around, play, dance, anything to kind of get your heart pumping, within reason or whatever. I don't want y'all like doing like, stuff where you could like hurt yourself or, really mess yourself up. But the main thing is, just try to a little bit, just get your heart going for like 20 or 30 minutes, dance, jump, play, laugh. Laughter is like, it'll keep you young. The better you're able to laugh at things and just like, don't take it so serious, it'll keep you young. But then when you start taking everything serious, I mean, it is serious, and it has its reason for having that energy, but keeping your heart light will kind of help you to kind of stay young or whatever, right? But you see, we have a digital printout, a digital version of what we just did by hand. All right. Okay. So we actually just introduced the x and y intercepts. That's what we started to do in the last one. The x-intercept is the point in which a graph crosses or touches the x-axis, and the y-intercept is the point in which a graph crosses or touches the y-axis. So the word intercept means cross or touch, right? So like when they say interception, then the opposing team has crossed the path and taken the ball from the opponent or whatever. And so it's like to cut the line or cross or something of that nature. So it's a similar notion here is what we mean by intercept. No, I don't want that. Go away. Okay. Let's keep it moving. So to graph using the intercepts, to find the y-intercept, we set x to 0 and solve. To find the x-intercept, we set y to 0 and solve. And then select as a checkpoint, we select a non-zero value for x and determine the corresponding y. So now we have essentially three notions. We want to plot the intercepts and the checkpoint, and then draw the line that connects these points. Okay. I think this one we tried to use the intercepts, so maybe not. I think this might, yeah, this is different because ours was equal to 0. So for instance, if we're going to find the y-intercept, we set x to 0. If we set x to 0, so look, here's a copy of the original. If we set x to 0, this term goes to 0. You see it here. The 5y comes out. Eventually, we get to 5y equals 12. If we want to solve for y, the inverse operation for multiplication is division. So then that means the y-intercept is going to be 12 over 5. For the x-intercept, what we do is set y to 0. So if we set y to 0, this term is gone. We eventually get to 2x equals 12. Divide both sides by 2. X equals 6. And then the checkpoint, some non-zero point. So we let x be 1. Right? If x is 1, we're going to get this. To solve for y, first we subtract 2. 12 minus 2 is going to be a 10. 10 divided by 5 is 2. So then we want to plot these three order pairs. We have 0, 12 by 5. We have 0, 6. We have 1, 2. So if we were to plot these points, you see them all here. 12 by 5 is 2 2/5, so slightly above, a little above 2. Okay. So for instance, this graph acts as the graph y equals 3. Notice that there is no x there, right? So that means what this is saying is that no matter what x we choose, y is always 3. So we could actually just quickly find some ordered pairs to plot. So again, no matter what x we choose, this equation is saying because there is no x, no matter what x we choose, y is always 3. So for instance, if x was 0, y is 3. If x were 2, y is 3. If x were -1, y is 3. You see what I'm saying? So no matter what x we choose, our y value is 3. If we plot those points, you should be getting an image in your mind, right? If we plot all those points, we get a straight horizontal line. So this equation can be written as y equals 3 plus 0 times x. So what this is saying is that for any value of x, y is going to be 3. So whenever we have y equals a number, that's a horizontal line. So if we can do y equals a number as a horizontal line, what do you think is the next idea? If y equals a number, then we could also talk about what? X equals a number. If x equals a number, if y is going to be a horizontal line, then maybe x is going to be what? Hopefully your intuition is saying a vertical line, and let's look at it. Okay. So the graph of an equation of the form y equals b is going to be a horizontal line whose y-intercept is 0, b. Okay, and then, right, now if we could do x equals a number. So hopefully your mind is saying a vertical line, right? So this equation can be written as x equals a -2 plus 0 times y. So for any y chosen, x is always -2. And notice we get our vertical line. So no matter what y value we have, x is always -2 in this case. Okay, so that's going to be a vertical line through x equals -2. So the graph of an equation of the form x equals some number is going to be a vertical line whose x-intercept is that number, 0. Okay. Surf shop sales. Okay, cool. So Carol works as a sales representative at a surf shop where she is paid a weekly salary plus a commission on her sales. She receives a salary of $300 a week plus a 7% commission on all sales. S. Write an equation for the salary Carol will receive. Let's see. Oh, is it already there? Okay. Will receive R in terms of her sales S. Since S is the amount of sales, a 7% commission on S dollars is 0.07 times S. So her salary is going to be the $300. Let me go like this. Her salary is going to be the $300 plus the commission. So the amount received is going to be 300 plus 0.07 times her sales, however much she sells. So she gets commission of 7% per each sale. And then graph the salary for sales of $0 up to including 20,000. So because our equation is a straight line, notice that the highest exponent is a 1. It's a straight line. So we can honestly just plot those two x values. If she sells $0 and she should get 300, if she sells $20,000, then we get another point, right? And we could just plot those 2 points. And then they said also do a third non-zero. Well, that's if we were doing intercepts. But it still doesn't hurt to go ahead and get a third point. So say we did 10,000. If S was 10,000 right here, that's going to be what? Move it 4 times, 1, 2, 700. Plus 300 is 1,000. Okay, so we can plot these ordered pairs. If we were to plot these ordered pairs, we get an image like this. So notice that since we're only going from 0 to 20,000, we don't put arrowheads. The arrows mean continue the pattern in that direction forever. But since we're only going from 0 to 20,000, we're not doing arrows. We're just going to do points or end caps or whatever. Okay. So from the graph, estimate Carol's salary if her weekly sales are 1,500, and these are in the thousands. So 15 is here, right? 15 is right here. So if she sells 1,500 in the week, then this is in hundreds of dollars. So how much she's going to receive? What is that? Like 13 something? Okay. So if our weekly sale is 15,000, you can take that and plug it into our formula, and you should get a number. You should get about 13 point something. Let's look at the result. Do we not have it? Let me see. Oh, there it is, 1350. Right? So it's an approximation, and then, let me see. That might be an approximation. What I would do is take that 15,000, plug it in here, and we'll get a number. Okay, we're going to let that be. From the graph, estimate the salary needed to earn a weekly salary of 900. So if she wants a weekly salary of $900, which is here, then if we were estimating, she needs to do between 800 and 900, so 850 approximately. 85, 8600. Of about 8,500, 8,600. We can actually find the actual number. Let me see. Substitute 900 in for R right here, and then solve for S. Okay. So with part C and D, it is recommended that you do that on your own. Okay. That's okay. Do that and get those numbers. And if you need support or anything, just reach out. Because we didn't work those last two examples all the way through, so you want to just kind of work them yourself and see if you can get those actual numbers. Okay. And let's go like this. We're going to go to paper, and I'm going to go here. Oh, can I not access it right now? I might not be able to access it. Okay, I'll have to do that once I exit this mode. So on that note, we're actually going to end this session here. I'll make a copy of this PDF available, and if you have questions, again, write them down and email me. But we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. All right.